BGP Part 8, BGP Multi-Homing Design Strategies. If you have gone through all of the BGP nuggets up till now, you have a very good grasp on the technical aspects of BGP, setting it up, configuring it, deploying it on Cisco devices. And I wanted to add this nugget to the series because of a cold reality shock that I had after I got my CCIE. Once I did get my CCIE, I found a lot more consulting work for Cisco. People just trust you a lot more if you have the CCIE credential. And I remember walking into a network, and this customer had multiple service providers and needed a BGP design to allow access into their company. And I went there, and they said, well, we want to set up our network for BGP, but we don't know anything about BGP. And I said, well, that's great, because I'm a CCIE and I know all about BGP. I've set it up, I've deployed it, and all that sort of thing. And they go, well, that's wonderful. So how do we do it? And I'll never forget the feeling that I sat there and I stared at them. I said, well, we need to set it up. And it was just, I just remember thinking, this isn't what I expected. This wasn't what I signed up for. I'm used to the CCIE lab where they say, you need to make BGP do this, make this network appear over there, do this, do that. And you have to know technically how to make BGP work. But nobody ever told me a company would come to me and say, we need you to design the company scenario for BGP. So what I had to do is I had to go back home, tuck my tail between my legs, and read some books on how to make BGP design work. What I want to do is I want to go through this nugget, giving you the three major scenarios that you'll run into with BGP in the real world. I'll first off go over quote-unquote multi-homing to a single service provider. Then we'll hit real multi-homing to a single service provider. And then we'll look at the most difficult design to do, and that is multi-homing to multiple service providers. So we're going to look at each one of those three design strategies, beginning with multi-homing, definite quotes around this, to a single service provider. The reason I even call this multi-homing with quotes is because I've heard a lot of people say, well, I'm multi-homed, and then I see the network topology, and this is somewhat of what I see. Now, this isn't true multi-home, because we only have one home, just different streets to get there. This provider is giving us our internet access. And in this situation, if you're designing this kind of networks, a lot of customers think they're very redundant because they've bought maybe dual T1 lines. However, if you're going to the same service provider, most of the time, these T1 lines are going to be in the same bundle. What I mean is going under the street, going to the service provider. So if a backhoe comes in and takes out that bundle, you'll probably lose both T1 connections. You also have this service provider as a single point of failure because most likely you'll be connecting to the same router. If this router goes down, you're going to lose your connection altogether on both links. So this, I would say, is the least cost, but at the same time, the least redundant strategy that you can have when connecting to a service provider. So what is the BGP design recommendations? Well, my thought is it's very rare that you'd even use BGP at all. Most likely what you would do is you would go on this router right here and create two static routes. A default route going out to one link and the default route going out to the other link. Now, if you just create two static routes and you say all zeros, default route 0000 goes to this IP and this 000 goes to this IP, well, the administrative distance will be the same, and you'll start load balancing across them. You will send some traffic on this, some traffic on this, and that's a way that you can utilize both T1 connections. If you want one of these, maybe one of these is half the bandwidth, it's a fractional T1, I'll put FT1. In that case, we might want this one to be a dedicated backup rather than a load shared connection. What we would do is we would create the same static routes, but we would crank up the administrative distance on this route. Go ahead and make it something like 200. So if your primary default route goes down, as in this link is lost, or maybe the service provider router fails, this one will plug in and take over, and that connection will be utilized. I have seen, I won't say I've never seen BGP used in this scenario. I have seen it used once. and the justification, I could see this justification, was that they wanted to be ultra sure, super sure, that these links were online. And here's what I mean by that. Static routes and the failover between them assumes that this router detects a link failure of some sort, as in the serial connection stops working. What it won't detect is some sort of service provider failure over here. Maybe this router, loses its internet connection, or the router freezes somehow, but the link stays up. Somehow that layer 2 connectivity stays online. Well, the static route at that point just creates a black hole because it's going to stay up and assume that link is okay. It really relies on the physical link failing. So by running BGP across these links, you do introduce some overhead, but you gain the benefits of BGP, and the primary benefit that you gain is those good old keep alives. By sending keep alives, you are going to test not only the physical and data link layer connectivity, but also layer 3 and even above that. BGP is an application layer protocol, so it's going to check and make sure that this router is truly online by sending keep alives. And if one of those links fail, then BGP can go over and use the other one. It's a rare circumstance, but I have seen it done that way, so that we can be sure to detect when one of these links goes down beyond the standard physical failure. The first real example of multi-homing comes in this scenario: multi-homing to a single service provider. At this point, we have separate routers with separate wide area network connections, which could be in completely separate geographical locations. As a matter of fact, I just designed a network like this for a client who had, I'm located in Arizona, they had an office in Tempe, Arizona, and this is kind of representing their main office. And then about a mile and a half away, they had a separate office that they were expanding into. That was their little branch office. They actually had multiple connections to 2 different service providers, which I'll be talking about in a moment. But you could have done the same thing going to the same service provider, and you have very, very similar design strategies as different service providers. The first one of those design strategies is advertising your internal networks to the outside world. I added a server to our topology because at this point, what I want to assume, since we're using BGP autonomous systems, is that we have internal networks that need to be reached from the outside. This could be a web server, or it could be an FTP server. It could be just about any type of server that you need access to from the outside world. At this point, we need to make sure that this internal address space, I'll just make one up here. Let's say the service provider assigned us 13.1.1.0/24. We need to advertise this internal address space out to the internet service provider to give it reachability. And we need to advertise it out both of these routers. So if one of these connections or one of these routers were to go down, we have reachability through some sort of backup router to get to those. Now, the first thing that I've seen, and the most common design I've seen, because it just works well, is to use a static route to do your advertisement. Let me show you how that works. This router right here is going to be in the system that is directly connected to the 13 network. So all I need to do is just a standard BGP configuration with my autonomous system number, and I'll actually talk more about autonomous system numbers in a moment. But I'm just going to go under there and type in network, followed by 13.1.1.0. And I would type in my mask, followed by 24-bit mask. That will allow this router to advertise the 13 network to this internet service provider router, and that will update its routing table. Now, what about over here? Well, what I would do is go on this router, and I would create 2 static routes. I would say to reach, and by the way, static routes is a common use. You can use a routing protocol to do the same thing, but here's the effect I want to grab. I'm going to say to get to the 13.x.x.network, I'm going to use the next hop. I'll type in a static route. I'm going to use a next hop that points to this interface's IP address. I will then create a second static route. Maybe this is my backup link. I'm going to point it over here to my tablet's running out here of room. I'm going to point it to this one's interface with an administrative distance that's maybe a little higher. I'll put 150 as the administrative distance because maybe this is the preferred connection to get there. So I've created 2 static routes to get to this network over here, and then what I will do is I will include the 13 network using this same command, little checkbox right here. Using that same command, I will include the 13 network in this BGP route advertisements. So this router will end up getting that BGP route advertisement. Now I'm going to tweak those attributes a little bit, just like we covered in the attributes part 1. I'm probably going to say, well, this is the backup connection because maybe this is coming in through a branch office. I want to add autonomous system numbers to the path, increment the AS path. That's the most common way that I've done it, to add autonomous systems to make this side look less desirable to the service provider than this side does. And at that point, this will be the preferred route. Now, here's how it's all going to work. First off, if this router loses, we'll say this WAN link and this WAN link, what's going to happen? Well, it has these static routes, and the next hop for those static routes will end up becoming unreachable. Or if we're using a routing protocol, the 13 routes will disappear from the routing table. At that point, the network statement that we use to put them into BGP, it'll still be there, but it will not go out. This router will stop advertising that it has the 13 network to this internet service provider up here. The service provider updates their database, and now they say, okay, that network is not reachable. Vice versa, let's say this router loses its Ethernet connection, or loses its, well, Ethernet connection, because the WAN connection would pretty much sever that right there. At that point, the network statement of 13 becomes invalid because its connected interface has gone down. Now, if we had set up a static route to go across this link as a redundant connection, that might work. However, it would probably be more efficient for it to come in through this internet service provider router in the first place. So with that connected interface going down, this network will no longer be advertised to the service provider, and the service provider will now fail over on this side and enter here to get to this web/FTP server on the inside of the network. So that's a way that you can advertise out your networks to the service provider and allow them to receive them and have redundancy for your crucial networks inside of here for reachability from that service provider. But what about the other way around? What if I wanted to implement load balancing for outgoing connections? You know, we have, some users over here, some users over here. Maybe this WAN link, I've seen people use wireless connectivity. For example, that office I just set up, they had wireless connectivity since it was only 1.5 miles away. They used satellites to get 11 megabits per second. I keep putting marks on my screen. 11 megabits per second between their routers, and that was a pretty good link. So they wanted to implement load balancing that would allow these service provider connections to be shared going out to the service provider. Well, there are about 4 different strategies that you can use for load sharing these different connections. And to show them to you, let me go ahead and clear all this gibberish that I've drawn on the screen, because this is for the incoming. Let's talk about outgoing. The solution is a lot simpler than most people think. And I say that because I've seen some pretty horrendous designs to try and implement some sort of load sharing and load balancing on these outgoing connections. For example, the most common thing I've seen done is that you have your different gateways, right? Your different IP addresses that all your clients, you might have 100 clients over here and 100 clients over here. The different gateways are being used to get out. What I've seen people start doing is they will start manually changing the default gateway on the DHCP scopes. So they'll try and manually do it in the sense that half of their clients will end up going out one gateway and half of them will end up going out the other. And it just gets, anytime you do something like that, it just gets pretty ugly pretty quick because there's no real magic behind it. Nothing is automated. It's all manual and up to the administrator to set what default gateway all the clients are using. The nice, simple way to implement load balancing is just to allow your internal routing protocols to do the magic themselves. We have these routers, and they're pointed going outbound, and they have a default route. Now, I say default route because it's very rare that we would need to get the entire internet routing table on these routers. I mean, what use would they really have for that? I mean, the most they would probably get is a few routes of maybe a branch office they're trying to find an efficient route to. However, we would normally have just a default route saying, for anything you don't know about, send it to the internet service provider. What we can then do is redistribute that default route into the interior gateway routing protocol, whether it's RIP whether it's OSPF using a default information originate, whether it's EIGRP having to do a redistribute static and just filtering it out for this static route. There's many ways to get a default route into your interior routing protocol. As long as you have your network and your internal network designed well, that will flood to the network. And I only have 4 on the screen, but you might have 10, 20 routers inside of your networks that's going to go between. And what will happen is the routers will choose the most efficient route out of the network, and that will automatically implement load balancing because, excuse me, the routers over here will have this default route that they're sending to all of the routers on this side that says, hey, I'm the most efficient route out. You don't want to cross that 11 meg link or this T1 line over here. There's no reason to do that. Just use me as the default route out. These ones will say, hey, you know what? I'm the most efficient route. Just use me. As a matter of fact, you get phenomenal load balancing if you have these routers co-located. Most people have a typical large campus style network where they have 2 routers that are located off the same Ethernet segment or something like it and go off to the internet service router this way. It's going to come down and you're going to have something like this where you almost get one-to-one load balancing going across both of these because your internal network is behind here. So it's very easy to implement outgoing load balancing. The other method that I've seen, and this does go back, I've seen it used all the time, back to the DHCP scope and load balancing that way, is I've seen people create HSRP groups between these routers. And they'll create 2 groups. So they'll have 2 phantom router IP addresses that are coming into the internal network. They'll try and manually point half of the clients to go out one phantom IP address and the other half to go to the other, and give the clients 2 default gateways for redundancy purposes, just in case one of these routers were to go down. That is another way that I've seen it done a lot, and that again goes back to the manual assigning of default gateways to the clients through the use of DHCP scopes. But that's load balancing outgoing. Is it possible to load balance incoming? There's a question for you. I mean, we have this 13 network that we said was over here. This 24-bit subnet that we created over here. Is it possible to load balance incoming connections? Because we just appended the AS path to make one look less preferable than the other. That's a great primary backup scenario. But what if we wanted to utilize the bandwidth on both of these links? Well, there's 4 major ways that you can implement load balancing on incoming connections. The first way is to get out our old subnet calculator. Who needs a calculator? We can do it in our heads by now. And subdividing the range that the service provider gave us. Let me draw it back up here. We had the 13, I think it was something like .1.1.0/24. What we can do is we can subnet that. I could go ahead and say, well, let's do a 13.1.1.0/25. Oh, I put 4, but I meant 25-bit subnet mask, which would end up giving us the ranges 13.1.1.0 through 127, and then 13.1.1.128 through 255. Those are the 2 ranges we would end up with this mask. I could then advertise one of those ranges out to the service provider on this link, and I could tweak my BGP advertisements to say I want to advertise just this first range out to this router, and then I'll advertise just the second range out to this router. Now again, redundancy would have to be taken into play in the sense that we would only advertise the second range out this router if the first one was down and so on. So you have to definitely plan for redundancy. But by doing this, what it will allow you to do is have half of the IP address accessed through one of the service providers and thus one of your links, and the other half accessed through the other service provider router and the other one of your links. Okay, so both of your links are then getting utilized, and that most of the time, if you have this big of a subnet, you are going to have multiple devices that are accessed from the outside. Now you can subdivide even smaller subnets. I mean, maybe you have a 27-bit subnet mask on a range that was given to you by a service provider because you only have a few devices. Well, you can still subdivide and allocate the addresses to your servers as necessary to kind of distribute the load between the different devices and then distribute the load between the different wide area network links. That's the first major way to load balance your incoming connections. The second method is a little bit easier in the sense that it falls on the hands of the service providers to do it. What you can do is enable BGP multipath support. And this is something the service provider has to do on their end. Because if they have paths into an autonomous system that are exactly equal or are equal enough to enable load balancing between, they can do it. As a matter of fact, let me show you. You can turn on, just like nearly every routing protocol that's out there, I can go into router BGP, and I've got a router in 7500, and I can type in maximum paths followed by the number of paths that I want to load balance across. And if I want to enable load balancing for iBGP, we can do that as well. However, this comes into play by default. The maximum paths is set to 1. So regardless how equal these links are, the router will be forced to only put one link into the routing table. In this case, you could get with your service provider and tell them, hey, could you do me a favor and tweak the maximum paths to 2 on your router so that you could have 2 or 3 or 4 different links that you can load balance across going into my system. The benefit of that is, number one, you don't have to subnet the range that they've given you and split it and have the multiple advertisements. And again, that's not going to be really equal load balancing at that point either. And the second benefit is just that you get a little more equal load balancing because it's going to see these links as equal paths, and it's going to start load balancing almost in a one-to-one style format. One conversation on this link for every one that you have on this link, and that gives you a truer load balancing feel coming into your network. The final method that we could use to load balance incoming connections wouldn't really work too well in this scenario, but let's go ahead and say we purchased another router. Oh, there it is. We flew it in and landed it right in the middle of our network. It's a core router. If we had this sort of configuration, which a lot of campus style setups do, what we would have and what we could do is make this router right here, this core router, the BGP peer. And I'll give it the IP address, just some easy to remember IP address, 3333. Now you'll have to work with your service provider on this, but sometimes they'll allow you to do this. They can set up eBGP multi-hop and peer, instead of with these routers, peer with this central core router inside of your network. And that central core router may not be just one router. Maybe you're using HSRP to share the load between 2 separate routers. Or maybe you have a 6500 series switch that has a route processor inside of it. And it's the core of your network with redundant route processors and so on. So it's not like a single point of failure here. It could be anything inside of your network. But the service provider peers with this device rather than these devices. At that point, these become just transparent paths to get to this device. And whatever method the service provider is using, probably static routes or something like it, to reach this device in your network, that will be the method that allows load balancing. Maybe they have just static routes equal for both sides of the network that say to reach 3333, use this one, and since they're exactly equal, it automatically starts load balancing across those connections. This router in the middle becomes the BGP peer. So again, make sure that you are using the correct commands such as the update source, the eBGP multi-hop, and make sure you have your network designed correctly, because this can be a dangerous method and can cause loops if you have your network designed incorrectly to the service provider, and it'll only happen once and they'll never let you do it again. So you need to make sure that everything is perfect before you can do this. However, if your service provider will let you, that is another method that you can use to load balance all those incoming connections. Now let's talk about this autonomous system number right here. I have 2002, which is a public internet autonomous system number that somebody had to buy and is probably assigned to somebody out there on the internet. To get a public autonomous system number, it can be a pretty painful process. I'm not talking about money. Well, it can cost money. I would say on average it costs about $1,000 in processing fees to get your own autonomous system number, which can be a factor for some small companies who's counting every dollar. So it does cost a little money, but really it's just a hassle. It takes time. You have to get with IANA and really register that autonomous system number, give them a good reason why you need an autonomous system, because they are scarce and they're hard to come by. So what you'll see, especially if you have a single service provider environment, is that people, instead of using real autonomous systems, will be using private autonomous system numbers. I'll go ahead and say 65501 or something of that nature that the service provider will give you. Then, either as you send it out or as the service provider receives it, this number will be stripped and then translated to the service provider's autonomous system. If you have a single service provider connection, it's pretty rare that you would use a real autonomous system number such as 2002. Most often, you'll be using a private autonomous system number. The only time you really have to use a real autonomous system number, and I use have to loosely, is when you are multi-homing to multiple service providers. Let's look at that environment. Multi-homing to different service providers is one of the most redundant configurations you can have, because typically your links will be redundant, your routers will be redundant, the service provider's routers will be completely redundant, and the service provider itself will be redundant. Now, let me also mention that most of the time, in my experience, it hasn't been the problem of the service providers. I have found most service providers to be very reliable connections. And if there's a problem, it's usually somewhere on the link, outside of the service provider, maybe outside of your premises. It's on your router or something in between there. But I've found the service provider to be very redundant. Nonetheless, it does pay to have multiple service providers because I have seen them go down, and I've seen service providers, even large ones, go down completely for a time. The problem, and the reason I say it's the most difficult, is because of the politics. You are going to be working with service providers that are competing entities to advertise your network out to the rest of the internet. Sounds simple, however, unless you're a very, very large network, you are going to have to get these competitors to work with each other almost directly. Here's what I mean. Let's say, now I kind of wiped out our server, but let's say we had that server here again, and we had that 13.0.1.0/24. Now this address space can be one of two things. It can be a provider assigned address space, meaning one of these service providers gave that to you from their pool of addresses that they've purchased for their organization, and you're kind of using it on loan from that service provider. Or it can be a provider independent address space, which means you went directly to the IANA, the people that manage all the IP addresses on the internet, and you said, I need an IP address range for my organization. Now, unless you are a very, very large organization, most of the time that won't happen. The reason I say that is I think currently we're at the fact that they will not assign anything less than a /21-bit mask to a private agency, to a private company, or a public company, because otherwise it just starts getting too small to manage. So only a very large organization would be able to purchase a /21 subnet mask and use an entire class of addresses, and most of the time that's going to be service providers. So most of the time we will be using, in our organization, provider assigned address spaces. One of these service providers gave us this range. Okay, there's the story. That's the IP addresses that we have. Now here's the problem. One of these service providers, and I'll pick two names, not to give any plugs or anything like that, but just two names of service providers. I'll use Sprint and AT&T. Two service providers that we are linking up to in this organization. Let's say Sprint gave us this 13 range, gave us 13.0.1.0. We now have to convince AT&T to advertise a Sprint range out of their network to the internet in order for this to be fully redundant. That way, if this link went down and we lost our connection to Sprint, AT&T would still pick up the slack and keep advertising that network to the rest of the internet, so people could be using AT&T to get into our network and reach our internal range. Now, it's not as hopeless as it sounds. I've made it sound kind of hopeless, but these competitors are typically used to working with each other in this kind of scenario. This happens all the time. Most of the time, it's just one of those things where you have to get one of them to bend, one of them to coordinate, and most of the time I've seen it in writing. These service providers will say, when you sign up, hey, we will do this for you. We will allow you to use other address ranges and advertise it through us. Where it really comes in and becomes a hassle is right here, this autonomous system number. Most of the time, if you are going to have redundant service provider connections, you will get a real public autonomous system number. And that means dealing with government, dealing with the IANA, and getting one of those assigned to yourself. Now, there is ways that you can use private autonomous system numbers with these differing service providers. The first way is that you can get them to agree on a private autonomous system number between them. Maybe both of them will agree that you use autonomous system 65501, just picking a private autonomous system number. And at that point, both of them will see you as that, and both of them will strip that for you as it goes out to the internet. If they do not agree, as in maybe they don't have an autonomous system, a private autonomous system, that they can assign you from both organizations, it becomes a hassle, but you can set it up and use a system called Autonomous System Translations. Here's how it works. As a matter of fact, let me go ahead and clear off this screen so I can have a clean slate. There we go. Let's say that this service provider over here on the left decided to give us Autonomous System 65501. This service provider could not accommodate, and they gave us 65502. Well, what we could do is in our network, we could choose one of those private autonomous systems, and we could say, well, I want to use this one. And truth be told, we don't have to use any of them at all. We could come up with our own private autonomous system, but again, it causes just more headaches. So typically pick one that one of the service provider gives you and configure your entire system. This would become 65501 as the autonomous system that we're configuring. Everybody is using that number. Now here's the command that you would use. On each one of these routers, and as a matter of fact, you don't really need to do it on the router that's connecting to the service provider whose autonomous system that you're using, but on the other router, we'll say this router connecting to this ISP, we would go, and let me type out the command, it's a little bit longer, we would type in neighbor followed by BGP Autonomous System 2001's IP address. I'll put x at x at x at x. That'll be the IP address of this router up here. And what we would say is local AS followed by 65502. What that does is it says even though we are configured right here in Autonomous System 65501, this router's in 65501, when we are peering with this neighbor in the BGP open message, I want you to pretend that you are from 65502. It's called number translation, and that allows this router to kind of put on a mask up here and say that it is pretending to be from a different autonomous system. The only problem that comes into AS path translation, or AS number translation, I shouldn't say path, is the AS path. That's why my words are getting jumbled here. The idea is that when you are sending your routes out, you're going to be leaving from your autonomous system, they will come up here and will be received by this router. Each and every route will have both autonomous systems. It will come out and show it's coming from 65502 because it does that because of that local AS number that you typed in. And then it will also show the path as 65501. What that means is this ISP must change their incoming filter to catch both of those autonomous systems and remove the private AS numbers for both of them and replace it with its real autonomous system. Some internet service providers may not do that. They may refuse to change their incoming filters, and more power to them. That's their company. They get to choose what they can and will allow and what they won't. If they do not allow you to do that though, this solution will be shot down. You can't use the AS number translation because if they don't change their input filters, they will reject your updates. And at that point, you have to go back to purchasing a real autonomous system number or somehow getting these two service providers to agree on one autonomous system that they can use. The final consideration, and most painful one, with multi-homing to different service providers is load sharing and redundancy. Figuring out how to distribute the load between these links and become redundant between the different service providers, having a primary and a backup service provider. What are your strategies? Well, on the outgoing side, it's a piece of cake, no problem. You can use all the same strategies we've been using up till now, just redistributing a static route into here, letting all the internal routing protocols figure out the best way out. That'll do your load balancing. You can even do HSRP with multiple default gateways if that's the method you prefer. Outgoing is no problem. Incoming, on the other hand, is brutal. And the reason I say that is because you're working with two totally different organizations, which probably have no communication between them whatsoever. Each one has their own link out to the internet, so it's really like you have two completely different autonomous systems that you're connecting to. For load sharing, the only possible solution that you have is to split up that range with subnetting and advertise that range to different service providers. Like I mentioned before, say you had 13.0.0.0/24, go ahead and make that a 25-bit subnet mask, advertise half to this and the other half to this, and really analyze your traffic load that happens on those different IP addresses. That's about your only solution that you're going to have. That's load sharing. On the primary backup scenario, that one gets a little easier, and the main design strategy that you can use is that AS path prepending. That's why I hit it so hard when we went through the attributes part 1 nugget, is because this is the primary method that we can use to prepend autonomous system numbers to make one of these look less desirable than the other. The problem comes in when we're using a private autonomous system number. This kills you, because if you prepend multiple private autonomous system numbers, they just get stripped off as soon as they come to the service provider and advertised out. So these paths don't look any more desirable from each other than they do in the first place. So like I said, it gets very, very difficult doing load sharing and primary backup between the service providers. The best bet that I've seen in the real world is really just to sit down with the service providers, call them up and say, look, this is what I'm looking to do. What methods, these are the strategies that I have, what methods do you support, and what method would you suggest to do if I want to use one of you as a primary and one of you as a backup, and even one of the service providers as a load sharing solution. They will typically have a lot of strategies that they support. And really, that's why I say politics are the brutal part. You're going to have to coordinate those strategies between the service providers to get it to work best for your network. In this nugget, we have taken a look at the 3 major strategies for connecting to multiple service providers and single service providers using BGP. And I hope at this point you have a better idea of what to do and how to design a BGP network when you're setting up to connect redundant service providers or redundant connections to the same service provider. I hope I've given you an idea of the options that you have, because that's really what you're going to need to throw out, because most customers have no idea about BGP. And they're not only going to need to know what to do to implement it, but they're also going to need to know the complete design of it. So I hope this has been informative for you, and I'd like to thank you for viewing.